opinions expressed in this show belong to the person expressing them. They do not purport to reflect the opinions or views of Rancher or any other entity.
Hello and welcome everybody to today's episode of Shipwreck Sunken Treasure. I'm going to do the Adrian thing and say welcome to everybody that joined the channel so far. So scrolling back through, I see Maz Hago, Wifebot, Nuno, Matthew Cooper, M. Laden, Bala Frank, Peter Keach. I think there's a couple other people in there, but thank you all for joining. I know you guys probably all missed having the show yesterday. Before I forget to mention it, the show is going to be picking back up in another couple weeks. I've talked with Adrian already. We've retooled it. We've got some new ideas humming along, and we should be good to go. And it should be a much more well-tuned show, and you'll and I think y'all like the changes that we're going to make. But today is my last episode in the current format. I wanted to make use of the effort that I put into the episode before we switched over. Today's episode, based on the chat in the community, or the poll in the community, is going to be based on auras and registry, and something that I recently added that I didn't actually add in the text, secrets. So without further ado, let's start. Let me introduce the rabbit hole that I'm about to take us all down, and then hopefully you guys enjoy the ride. So I hope you're all sitting down and comfortable, but if you're not already familiar, secrets in Kubernetes are not really secret. They're just base64 encoded, and that's something that always disturbs me as a consultant when I have to introduce people, and people often ask, like, why is it called a secret then? And generally speaking, I run into, once I get that question, I usually say that, well, your secrets are normally provided or solved by either the cloud provider that you're running in, maybe a key store, or something to that effect. There's a host of secret solutions that aren't built into Kubernetes, but they don't always fit you. There's going to be, so for instance, if you're not running in AWS, Google, or Azure, you're not going to have access to a vault. If you're brand new to Kubernetes, then you're probably not going to be familiar with how HashiCorp Vault has set their secrets up. There are other one-off tools that Adrian has had in his show. One of them that kind of inspired me to go down this path was the secrets init, solution. But as you can see in their repo, that they themselves are also using Secrets Manager and Parameter Store and Google Secret Manager. And to add a couple another couple secret solutions out there, I know that there's also a lot of CI-based solutions like sealed secrets. There's SOPs with the Flux operator, and I know there's a couple other ones out there. But I really just want the secret to be as Kubernetes native as possible. I don't want it to include a lot of extra installation on a. Thank you, Bala. External secret is also one, and there's also the CSI-based secret solutions is available. This is an exhaustive list, but I haven't been happy with one that feels like it just is meant to be with a Kubernetes that's attached to like my local machine, or to an air-gapped Kubernetes, so that I don't have to install and maintain another component. And so I dug around, and I was playing around with something called auras. What auras is, as I think I had previously mentioned in an episode, that's going to be a storage solution. It's going to extend your ability to store things in a registry. So normally in a registry, you see images. Auras is going to give you the ability, if you follow along in their instructions, to add just basically any sort of config flat file that you want to add into an OCI registry, and then pull it back down. I got to thinking with that. I don't know what I was doing at the time, but I also was sent to something called Containerd Image Crypt. And what Containerd Image Crypt is it's going to allow you to encrypt things that are going into a registry. And interestingly enough, ORAS is based on imports some of the container D components. Just as an example, if we look at package ORAS, let's just look at pull. You can see that a lot of what they're doing is based on container D. So putting the two solutions together shouldn't be that difficult. To spoil the idea, I haven't fully implemented this yet, but I have proven out the individual components. More work to come on making it a full solution. But the idea is that, let's look at an instance here. I have a Kubernetes cluster. In this Kubernetes cluster, I have a runtime. I want to mount secrets into the runtime, either as environment variables or as files like the normal secret solution does. But I want to make sure that they're only available when they're being pulled from the system. And so what I've got here is I've got an example, and this is kind of a conflated example, but bear with me here. We have registry, which is in fact the Docker registry. Let's actually view this as YAML. Scroll through the managed fields. You can see that this is just a standard registry distribution, exposing port 5000. There's also a node port. I was testing around with some things, but there's also the ORAS sidecar container. So the basic idea is that I want to create a controller that's going to automatically inject the ORAS sidecar, have that ORAS associated with a secret that you're going to pull down. That secret is going to pull down from the given registry that you should have, because you're already pulling from some registry somewhere, and making sure that that is encrypted. And I ultimately want to get it to the point where it's encrypting things in the context of the init container of the actual container that's running it, kind of like the secrets init container was doing. But that one, again, a work in progress. So to prove out the individual components, we'll look into the ORAS container. The ORAS container was really great. Like Nuno just said, Deus Labs is really cool because I didn't have to do any additional configuration. I just added it as a sidecar, and then the commands worked as expected. So if we go into that sidecar, into the ORAS sidecar, execute shell, you can see that I have ORAS. ORAS help, log in, log out, pull, push, version. But because the container that's beside this in the pod is the registry, I can just refer to that localhost 5000 for that setup. Going back into ORAS, you can look at the example, and I'll take you through the example here. Basically, we're just creating an artifact.txt. That artifact, I can make that a little bit bigger. Echo hello world artifact.txt. In the case of the secrets, we would want probably some YAML file or maybe just some key value system. We're going to push that to the local registry, and then we're going to pull that down. It's going to be pushed and pulled from the same location, but for the sake of experimentation, let's assume that that's a remote registry that I've set up all the TLS for. So we're going to go back into, let's copy this command, go into the Rancher workspace, echo hello world, see that artifact.txt exists there, and we'll push that to the local configuration. One thing that I spent far too much time investigating was the OCI spec for the manifest configs. At some point in time, if this does become a fully fledged product, I am going to want to make sure that I put an actual secrets resource as part of as an artifact with proper APIs and everything like that. But for the purposes of this POC, I didn't do any of that work. So we're just going to use just a generic manifest config. Copy that, paste that, we can see that it pushed to the localhost registry, hello artifact. Going back into auras, we could remove that. We probably should just to prove it out entirely. Paste. Confirm that it's not there. And then from auras, we're going to, we pushed it already. Let's do the pull. And we do an LSLA. We can see artifact.txt is back. Cat artifact.txt just to prove that I wasn't doing anything weird. Hello world is there. It's really straightforward. The solution works as expected. There's currently activity on it. The last push was 4 days ago. The last release was 29 days ago. So it's not like it's one of those projects that's withering on the vine. Nuno just made a comment. This week, I lost access to my WSL environment, and on top of that, I lost access to the Windows terminal. So I'm using Rancher to interact with that pod right now. I have an Alacrity environment set up, but I'm not too fluent with that right now. So I'm just going to do whatever I can through the browser. So now that we have auras working, the next more difficult part is to introduce the image crypt signature components to the host. To give a little bit of background on that, this is all going to be Containerd. This is a sub-project of Containerd. You can see that it's a non-core sub-project, so it's something that you're going to have to add to your installations. Hopefully, at some point in time, it's a little bit easier to add because right now it seems a little bit, I guess if you're a systems admin, you're going to be able to add it pretty easily, but it's not something that a general user of a Kubernetes platform would really have that much knowledge of or be able to dive in and interact with it. So what you're doing here is you're basically just going to make the Containerd and all of the binaries required to run image crypt. I know I've publicly complained about makefiles before. When they're associated with lower level components like this, I honestly think it makes sense. But for standard binaries that you might be running in the Kubernetes context, I think that's a little bit overkill. So you can see here, it's just going to install, put some things in, create some binaries. And the binaries are going to be container encode, container decode, and I think Containerd as well. The interesting thing here is that they've defined this such that you're running a separate Containerd, even if you're already running Containerd on the host, just so that it doesn't collide with maybe like the Docker installation. You can see a Docker installation, we use temp for directories. Oh, so they don't install it. They build Containerd 1.3 from the source, but they do not install it. But the main focus here is that we're going to be running Containerd. We're going to be passing it in a config.toml. And then there's going to be the types that we're going to be accepting. The encrypted gzips, the encrypted tars, and we're going to be able to decode those as well. Yeah, so we can see the first category is encrypted gzips, the second category is encrypted tars. If you're following along and you're familiar with the auras project, I would have to create a separate stream processor so that I could decrypt the secrets object because it's not going to live off of VND OCI image layer v1 tar. I mean, technically it could, but I would want to set it as a standalone resource. Once we have that running, and just to prove that we do have that running, let me go over to my other host, make sure that that's large enough. We will go into home image crypt. We can see that I've already gone through some of it. You can also see that nerdy control is put there. I'm going to hop back over to the browser. Well, actually, we should be able to see Containerd running in the context that, yeah, it's there. We're going to clear out of that, clean that up. we're going to rerun this because I think that this is running as a separate process. Oops, I need to do this. I need to point to the actual containerd distribution. Containerd is not there. This is an RK2 instance, and for those of you who aren't familiar with RK2, RK2 moves the containerd binaries around. So I'm going to go in here, go off screen. You guys can't see what's going on. And I will export the right information so that containerd is set by default. Varlib. There we go. So the path is now varlib rancher RK2 bin. Export. Containerd should be there. Containerd is. We clear through that. And then we're going to do this command, but we're going to replace there we go. I should have done that as a background process. You can see that there's nothing problematic happening. We have an error, and we have some of the file system configurations. Those didn't seem to cause too much of a problem, so I just accepted them and moved on. Yeah, hopefully that boots up quickly enough. Going beyond that though, once you have containerd with this configuration, you have the ability to pull down and decoder. So yeah, just to pull down the encrypted images. You want to generate an RSA key. That one's pretty straightforward. They're just going to use the OpenSSL command. I've done that already. I've done the second command, which is going to be to create a pub key for that. And then I change the containerd.sock. If we go into here, let's actually go into my other terminal. That node does not seem to be complying with us. It might just be my network right now. Thank you for coming, Peter Keach. So continue on, assuming that at some point in time we have access to this node. I think I might have broken it. I'm going to set the new container runtime command as container encode, and then I'm going to point it at the running containerd socket. Once we do that, we're going to pull a test image, check the layers of that test image, whether or not it's encrypted, do the encryption with the given public key that we have, validate that the encryption happened, and then store that in a registry, and then validate that pulling it and pushing it is going to require a key, or running it is going to require a key. So let's see, status here, connection timed out. I might not be able to do this live demo. Running that additional containerd might have caused problems. Give that a second to fire off. I think by creating the other process, it might have cleaned up. It might clean up at some point in time. But one thing I do want to point out is that this is all well and good. This is a manual operation if you want to do encode and decode things, but the ultimate end goal for this is that we want to run it on Kubernetes. Thankfully, they've already gone through and created a document for how you might configure it with a given node architecture for Kubernetes. That's stored, they had a link for this here somewhere, but that's since shifted with the release of, with one of the repo migrations. And so I just want to point out that it's now living at containerd /docs and then /CRI, and then in decryption. So signature verification, Moz, is going to be another topic entirely. At this point, it's just keys. Although that is something I'm interested in. So this container configure image decryption is going to work on the node key model. Basically, you're just going to load your nodes with some keys, maybe give one node access to different keys. That would be something that you would automate. That one obviously take a lot of process. You'd want to secure that process, because if you lose access to your keys, then the whole point of doing this is null and void. But the main idea here is that in addition to the other stream processing args that we had in the previous example, we just have the decryption keys path. So that it's just going to look at that directory and decode things based on those decryption keys. Configured as that, and then decryption keys path. Yeah, that's what this last statement is explaining. I still don't have access to this environment. I must have, that last command must have corrupted, or I don't know exactly what it did, but I think that's going to make it so that I can't go forward with that environment. Let's check that environment from the Kubernetes API. Seems like the cluster is still up and running. We still have access to the registry. I was trying to run the encoded image from a public registry, but I didn't have TLS set up, so Kubernetes is going to complain here. But the registry and the containers still seem to be running. Yeah. Let's try and look at some additional components. Let's exec shell into here. Change directory. Just from my agent. I wonder what's hosted, what mounts are hosted. Yeah, I won't spend too much more time since I do only have 7 minutes. A live demo is not going very well today. But it does seem like my streaming setup has been corrected, which I'm very excited about. Back into the image encryption, just to kind of wrap up. So the idea here, once you have access for the nodes themselves to have sets of keys, to be able to pull the encrypted images, then ORAS is just going to be able to pull the encrypted image. There'll probably be an additional process that does some additional moving and restructuring of that output, but then as opposed to storing secrets using Kubernetes secrets, your secret process is just going to be to upload artifacts to OCI and pull them down with a sidecar configuration to each of your workloads. Curious if anybody thinks that this solves a use case and that this is something that they might deploy, or if they see any major vulnerabilities here. So I'll keep an eye on the chat if anybody has any red flags that they want to send my way. It was just an idea I had, and because I'm not running a terribly qualified production instance, it's okay for me to test around with it. But a lot of you are SREs in your own environments, and you might be a little bit more sensitive to security concerns. To go into a little bit of depth, one of the reasons why I use nerdctl. Oh, actually, no. One thing I do want to mention, if anybody is following along after the fact, even though I couldn't actually go through some of the other examples, if you're using the Docker registry commands here, the CTR images push, CTR images remove, you're going to have to, just with the Docker run commands here, you're going to have to specify a -- plain HTTP code flag on top of those, because those are going to assume that it's running off of HTTPS, and it isn't. So you want to actually get there. One last check of the environment. No, it's completely dead. That might actually be the wrong IP. One second. What is the IP of that host? We will close this guy. We will look at the ARC82 nodes. It's 206. Oh, now I was going against the wrong host. That's what I get. So just to prove things out, I have a /keys directory. In there, I have my key, my public key, and then if I can quickly go through and prove out the encoding, I've already loaded it into the registry. So we're going to pull that down. And we're going to do first we need to set CTR. CTR equals this. We'll prove that the CTR command works. CTR images. Connection refused. I believe that I'm no longer running the containerd properly. So let's do this. But instead of this, we're going to do var lib rancher arc2 bin containerd. This time we're going to put it as a background process. We now have containerd running. We should be able to run that layer. To do this, I also have to make the currently running containerd socket available. I don't remember where that containerd socket is, and we're about time, so I guess I'm just going to have to cut it off right here. But one last check, actually. I'm going to do something off string. Give me a second. Going to look up my ARC82 cheat sheet. The containerd sock is living here. It's not there. So I'd have to pull it down and re-encrypt it and everything. I'm not going to have time to do that in the remaining 2 minutes. But like I said, let me know in the comments or anything that if you're going to if you feel like this is a worthwhile a setup to run, or if I'm completely missing one of the publicly available secret solutions that I can just go to and adopt right now. But beyond that, thank you for watching. And like I said at the beginning of the show, we will be back in a couple weeks. Keep track of the CNCN community site and at the Discord channel for updates on that. And beyond that, have a nice, wonderful weekend, everybody. Cheers.